Now that we understand the range constructor, we're going to look at constructors for other types. So all of the other built-in types that we have covered thus far have their own constructors as well. Now, this is not the typical way of creating an object or a member of that type. You usually just use the normal way. So we've talked about this a lot. So for Booleans, you just write true or false. Integers, you just write the integer, and so on. But there are these constructors. They do exist. I want to cover how they exist. They provide a different way to create a new object of that type. They also provide ways, they provide other functionality that is not just built in with creating the literal values the normal way. Okay, so we're going to go one by one through these constructors, beginning with the bool constructor. So it converts its input to Boolean, which is either true or false. So remember, this is like a factory that is creating Booleans, and Booleans are simple. They're just true or false. Let's go ahead and see how the bool constructor works. And the way it works is we just type in the word bool. It'll turn light green and open and close parentheses. And we're going to first start off by converting integers and floats to Boolean. So you might, all right, how can I convert an integer or a float to Boolean? Well, if you put in just any integer, let's just put in the number 99, it will return true. So it takes that and it evaluates this as true. Let's look at a different one. Let's say negative 99. That also evaluates as true. Let's look at the number 1. That also evaluates as true. The only number that does not evaluate as true is 0, which evaluates as false. So every number, if you pass it into the bool constructor, will return true except for 0. Floats are the same way. It doesn't matter. 99.9 is true. 0.0, which is just a float version for 0, is false. Everything else will be true other than 0. Okay, so that's pretty interesting how the bool constructor works. The bool constructor can also be passed the object none. If you recall, this is part of the none type. This is a singleton. It's the only member of that type. So converting none to Boolean evaluates as false. So there is no true for the none type since this is the only member of that type, and so it converts it to false. So it's pretty interesting. Python has a way of taking other objects and sort of making them or forcing them to be Booleans. And it's pretty simple. If it's any value that's not 0, then it is true. You can think of none as like a nothingness, so that makes sense that it's false. You can also convert strings and lists to Booleans with the bool constructor as well. So let's just say I have some string like Python, and if I pass this into the bool constructor, you're thinking like, oh, this doesn't make any sense whatsoever. How can a string have a value over here, a Boolean value? Well, it evaluates as true. Let's look at a few more strings. Let's look at a 1-character string like A. That evaluates as true. Let's look at an empty string. And this is the only string that will evaluate as false. So emptiness, like nothingness, evaluates as false, just like the object none evaluates as false. So you might now understand how Python treats maybe a list. Let's create a list inside of here. So I've created a list inside of the bool constructor. I'm passing in a list. So Python will evaluate this as true. And you might think, okay, what is the one type of list that it will evaluate as false? And if you guessed an empty list, then you would be right. So the empty list evaluation is false. So there's some sort of truth value for other objects in Python. So this is actually pretty interesting. It'll come up later in more advanced, Python, programming, is that there is this inherent like true or falseness about particular objects. So integers, floats, none, strings, and lists, they all have this truthiness about them. And that's how the bool constructor works. It always returns a Boolean, either true or false. We're now going to move on to the other constructors for the other types.